I'm Mr. Testtubehead, and I'm here to talk to you about complete and incomplete combustion. So let's begin. What I have here, this setup, is a simulation of a house, and we're going to look at how methane or natural gas burns. So we're going to look at this reaction here, which is the complete combustion of methane and oxygen. If things work out well, the only thing we would make is water vapor at the top. We can also make CO2, which is mostly harmless to us as long as we don't fill the room with it. More than about 10% and it's game over. But if combustion is not complete, we are going to make carbon monoxide and carbon. Carbon is also known as soot, and this is a very lethal mix. So the setup I have here is a simulation of the envelope of a house, and I have two detectors in there. The first detector is for particulates, particularly 2.5 micron particulates. These are a long-term health hazard. The detector on the right, the red one, detects carbon monoxide. So we're going to observe these when the Bunsen burner is burning clean and when it's burning dirty, or what we call very rich, and we'll get a pronounced yellow flame. The burner I've got set up down here, and we're going to vent it into this upside down beaker. There's no reason for that beaker other than it's shielding the top of the container from a little excess heat. That beaker is Pyrex. It's much more heat resistant than the tempered glass that the container is made out of. So it's just a shield. And you're going to see, even with plenty of airflow underneath here, we will still accumulate a toxic level of gases fairly quickly from such a small flame, and then we'll discuss where it comes from in our daily lives. So let's begin. The two displays have now stabilized. So what we're interested in is the PM counts on this meter, not the total volatile or the HCHO. Keep your eye on the PM windows. And on the right side detector, there's only one display to look at. When I start the gas flow, there'll probably be a spike in particulates when I strike it up and get it burning, but we'll let it stabilize for a few minutes then. And we've gone into 34 micro frowny faces on the left. The frowny face is the metric unit for air particle pollution. The pre-metric for frowny faces was bilious complexion. A single Bunsen burner trapped in what looks to be about 2 cubic foot box. We now have no carbon monoxide in there at all, and we have nearly zero particulates. Now I'm going to fully choke the flame, so it will be burning as intense of a yellow as I can get it. So virtually oxygen-free flame, which makes it highly polluting. The autofocus is having a bit of trouble because there's actually heat waves in the tank now. So it's only been about 10 seconds, and already we're seeing carbon monoxide production taking place in the box. So I think what's happening now is I've created a convection cell, and so I can feel the heat coming out of the box. So that's why the levels are dropping. I'll zoom out and show you what I mean. What's happening now is the heat of the flame is rising and rolling over. I can feel a wind coming out the front. So it's the reason the levels are stabilizing. If I had this drop to the countertop, the levels would be much higher, and we can do that in a future video. I just have to rig it up a little bit better. You can see the flame here, the way it's burning, highly yellow. If I readjust it to where it should be set, which is there, nice clean burn, the alarm should go off in a few moments. 50 is the level at which you can work an entire day in according to OSHA. At this point, unless there was something really wrong with you health-wise, the 10 parts per million would not be, for most people, would be unnoticeable. However, if you saw 10 ppm in your house, I would investigate that. I'm getting precisely 0 in my home, 0 in my vehicle, and I could not find higher than about 20 where the buses wait. So 10 in a house, that might be something that's going to turn to 50 or 100 one day. So I would have it investigated. You can see from this side what was once a clean beaker is now burned black with the product of incomplete combustion. Okay, that's the soot. Now this is all clumped together. The particulates are incredibly tiny. So this large scale soot is not of any concern really, it's just dirt. But if you see that accumulating on the walls outside your house where the vents are, that means you're burning too much fuel. It means there's not an air supply getting to this. So again, you can see how much soot has been produced during the incomplete burn. And that's what we want to avoid. The soot's going to take years to hurt you unless it was incredibly high and you had heart problems to begin with. This stuff can be inhaled directly into your lungs, and it's small enough, some of it, to go directly into the bloodstream. It's turning out to be very hazardous, but it's long term. But if this soot is being produced, I guarantee you, so is carbon monoxide.